Good morning, good afternoon, good evening. Welcome back to Chapter 15. We're currently talking about the history of life on Earth. We finished up with this graphic in the last video. I want to start with this graphic again because this graphic is really important. This graphic is very meaningful. Remember, the four different colors that we see at the bottom. This stretch right here is the entire history of the planet, the entire age of the Earth. How long ago is this point right here? This point right here is 4.6 billion years ago. 4,600,000,000 years ago. That orange line is 4 billion years long. This break between the orange and this light blue, that line right there is 600 million years ago. And if you want to talk about the age of things, how long ago was 600 million years? It is an inconceivable amount of time. If you were to only win the lottery once in a million years, how many times would you have won it since then? You would have won the lottery 600 times. This was 600 million years ago. A lot of dates we're going to talk about in a little bit. I want to put them into perspective. The first thing, what are the oldest fossils we have? The oldest fossils that we have were bacteria. When you think fossils, you think one thing. Dinosaurs! When you think fossils, dinosaurs are the first thing that come to mind. We are nowhere near close enough to be talking about dinosaurs yet. What are the oldest living things? The oldest living things were bacteria. What are the oldest eukaryotes? Things like algae. And we don't actually see eukaryotes until about 1.8 billion years ago. And then this distance right here, single eukaryotes to multicellular, that 1.5 to 1.8, that's not very long. How much is the 0.3 difference? The 0.3 difference is 300 million years. 300 million years ago was before the dinosaurs. 300 million years ago was before there were even dinosaurs. That's what that 0.3 means. It is not an insignificant amount of time. It is a huge amount of time. Our oldest eukaryotes, remember, our oldest living things were bacteria. They showed up about 3.5 billion years ago. And for about 1.5 billion years, they were the only living things. We get our first eukaryotes at about 1.8 billion years ago. Another 300 million years later, we get our first multicellular eukaryotes. Things like really complicated algae. It's not until 700 million years ago, again, basically it's 1 billion years after this, that we get our first animals. Oh, finally, dinosaurs! No, we're not talking about dinosaurs. 700 million years ago, the first animals, what were they? Like jellyfish? Like worms? Like stuff so strange and alien they don't even look like anything we find on the planet today. We're still not talking about dinosaurs because a dinosaur is a vertebrate, right? It has backbone, it has bones. Our first vertebrates didn't show up until 610 million years ago. 90 million years after our first animals. You know what was happening 90 million years ago? There were actually dinosaurs on the planet 90 million years ago. The dinosaurs had about another 30 million years until they all died. 610 million years ago, that is that breaking point between the orange line and the blue line. We finally see our first animals right there at that first breaking point between what's called the Pre-Cambrian and what we're about to talk about in a minute called the Paleozoic. Oh, our first vertebrates. Good. We're finally talking about dinosaurs. No. If all living things started in the ocean, then what are your first vertebrates? They're fish. What's the oldest fossils? Bacteria. What are the oldest animals? Like jellyfish. What are the oldest vertebrates? Fish. Not dinosaurs. The Pre-Cambrian ended with the largest known extinction event. All of those lines that we saw on that previous graphic, making the breaking point between different ages of Earth history. Each one of those lines is an extinction event. Each one of those lines is a mass extinction. And the breaking point between the Pre-Cambrian and the Paleozoic is the largest mass extinction in the history of the planet. 95% of all known species died. Not all known individuals, not all known animals, 95% of all known species. If I have 100 separate species and I've written them all down, and each of these species have millions of individuals, only 5% of the species survived, and probably only 5% of the population of those species survived. Think about that. 95% of all species gone. After every mass extinction, you have a massive speciation event. Speciation event means a bloom in new species. And the reason why we get these bloom in new species, I want you to think about it. Think about an ecosystem like a store. There are different jobs to be done in the ecosystem, right? There's producers that are making the food. There's consumers that are consuming the food. There are decomposers that are cleaning up the messes, right? There's a bunch of different jobs to be done in that ecosystem, and there's something doing it. In a store, there's a bunch of different jobs. There's cashiers, there's stockers, there's security, there's the pharmacy, there's managers, there's janitors. There's a lot of different jobs to be done. And if you want a job at that store, there has to be an opening. And the only way you can take somebody else's job is to be better at it than they are, which is really hard to do because you have to do the job to be good at it. And if you can't do the job because somebody else is doing it, then you can't be better at it than they are. It's really hard to take over the job of someone who's already doing it. But what if some global catastrophe happens? Like, I don't know, a virus comes and wipes out a huge percentage of the population. What if suddenly 95% of all of the employees of that store are dead? Well, there's a whole lot of jobs to be done now. And now, because you're looking for a job, you're looking for something to do to support your wife and kids, now you can get a job because there's a lot of jobs that are open. When the planet gets wiped out, when most living things, not all, when most living things get wiped out, we suddenly have a whole bunch of jobs that aren't being done. And so very rapidly, that punctuated equilibrium that we talked about in the previous chapter, very rapidly what happens is a whole bunch of new species show up as small populations are able to branch out into areas that are no longer being used, branching out into jobs that no one's doing now. It's like, well, if nobody's doing the job over here, well, I'll just go over here and do it. And now we're talking about separations by food choice. If we've got a whole group that separates from the other group because they're choosing a different food now, they're going to be separated. That's those pre-zygotic barriers. That massive speciation event is referred to as the Cambrian explosion. The Cambrian explosion was not an actual explosion. The Cambrian explosion was an explosion of new species after this extinction that ended the Pre-Cambrian. Mass extinctions. There have been at least 20 of them in the history of the planet. Each breaking point, and within any history there are smaller breaking points. Each breaking point in the history of the planet, it revolves around a mass extinction. Why did we divide this time from this time? Because there was a big mass extinction event between those two areas. Some of these mass extinctions were as small as only 35% of all species died, whereas some are as large as 95% of all species died. Mass extinctions. There have been a lot of mass extinctions on the history of the planet. We're currently in the middle of one. The background, the current extinction rate is about 20 times the background rate. Species are dying at an unprecedented rate right